Hello everyone, I am Shwadip Shaw and I will be presenting to you GSM Symbolic Understanding the Limitations of Mathematical Reasoning in Large Language Models. This paper has been accepted in ICLR 2025 by researchers from Apple and Washington State University. So, this is the outline. Now, the fundamental question that this paper is addressing is are large language models really capable of logical reasoning? While LLMs show impressive performance on their benchmarks like GSM 8K, the authors raise critical concerns. Like a single point metrics may be misleading, there is a risk of data contamination. A static benchmark don't allow controlled experiments to truly understand reasoning capabilities. So the GSM 8K provides 8,000 grade school math problems with a fixed test set. But the major limitations are there is no variance estimation, the potential contamination is also there. You cannot control the toughness of the test, and you can't test the robustness as well. So the authors concluded that we need a better evaluation framework. So they started with GSM symbolic. They converted the GSM 8K problems into symbolic templates with variables. For example, replacing Sophie with name, 31 blocks with X blocks, creating templates that can generate diverse variations while maintaining the same logical structure. So this approach enables multiple variants, 50 per template, giving performance distributions instead of single points. So you can control the difficulty systematically, and you can also test the robustness to the different changes. They created 100 templates, 5,000 total questions, and evaluated about 25 plus models. So, what did they find? First, they found out that all models show significant variance, plus or minus 2% on different instances of the same question. Gemma 2. Gemma 2 9 billion drops from 87 to 79% on average, with 12% gap between the best and worst performance. Remember that these are essentially the same questions with just different names or numbers. The the finding, the another finding is the data contamination. Even more striking, for 21 out of 25 models, the GSM 8K performance is more than one standard deviation than the GSM symbolic mean. Performance drops range from 0.3% for GPT-4 up to 9.2% for Mistral. Now, this strongly suggests that GSM 8K test questions appeared in training data, inflating the reported performance. The second finding was sensitivity to changes. The authors tested changing only names, only numbers, or both. When only name changed, the performance stays relatively stable. When numbers change, there is more degradation. When both change, maximum degradation and variance. This reveals that the models are performing uh, pattern matching actually, rather than for formal reasoning. Even superficial changes like names can affect performance. The another thing is they created difficulty variants by adding clauses. Results were very dramatic. Yeah. Gemma 9, Gemma 2.9v goes from 84% on the easiest version down to 42 when the two clauses were added. That's over a 40% drop. The variation, uh, the variance also increased substantially with complexity. This non-linear degradation suggests that the pattern matching is exponentially harder, not the controlled degradation we'd expect from genuine reasoning. The fourth finding was GSM no-op. So the most striking finding the GSM no-op is they add seemingly relevant but ultimately irrelevant information. For example, Oliver picks 44 kiwis Friday, 58 Saturday, Sunday, double Friday's amount. How much total? Now the GSM no-op uh, provided sorry so the catastrophic drop is no I think yeah. So the correct answer was sorry the correct answer is 190, but the size is irrelevant to the count, but model computes 185 subtracting the 5. So they blindly convert irrelevant information into operations. Now the next finding was the performance drops, the catastrophic performance drops. So 5.3 mini drops 66% points, Gemma 2.9b drops 63 points, even advanced models struggle. GPT-4o drops 32 points, O1 mini 29 points, O1 preview 17.5 points. And here's the interesting part, providing 8 shots, examples of correct reasoning does not help either. N- Neither does showing examples of ignoring relevant information. This suggests that the fundamental issues that can't be fixed by prompting. Even O1 struggles, like when asked how much to pay now, with a mention that the prices were 10% cheaper last year, it calculates that this year's prices and uses those. This inflation is completely irrelevant. We need current prices, where the model blindly applies it because it seems related, right? So is it just a math-based issue? Is it a math-based issue? So basically, no. The authors carefully controlled this whole thing. Models achieve over 95% accuracy in 3-4 digits arithmetic, and in context mathematical accuracy is exceeds 97%. The drops are due to reasoning fragility, not the calculation error. So the pattern matching hypothesis that they have actually concluded is LLMs perform probabilistic pattern matching, not for formal reasoning. The search for similar training examples match abstract patterns and replicates solution steps. Evidence include token bias, high variance, sensitivity to irrelevant information, and non-linear degradation. This isn't genuine understanding. It's a training dependent and fragile. So does fine-tuning help? Well, they tested the fine-tuning 3.5 on easier problems. Result is performance improves slightly, but harder problems, the performance actually decreases. Scaling training data won't alone solve the reasoning l- limitations. So, what does this mean? The implications are important. For evaluation, a single point metric set is insufficient. We need a distributional analysis for model development. The current scaling has fundamental limitations. Pattern matching is not understanding. For training, we need better reasoning mechanism and potentially different architecture. So GSM Symbolic provides a template for better benchmark. So what is the key takeaway? So to summarize, GSM Symbolic enables distributional evaluation. LLM shows significant variance in identical questions. Performance is fragile to superficial changes and degrades non-linearity with complexity. So, what is the final thought? So, the LLMs are capable of genuine logical reasoning. Current evidence says no, not in the formal sense, but this opens up exciting research directions towards building truly reasoning AI systems. So, this data set is available in GitHub. Uh, Thank you.